Hello, everyone.
Hello. Good afternoon, Ben. How are you today?
Hi. I'm very good, thank you. And thank you so much for inviting me to come and talk today. I'm only a little bit sad that it's virtual and that I can't
Mm.
be with you there in Ukraine today. But hopefully next year.
Of course, we all hope for next year. And thank you very much for supporting us in online format. I know it's a bit challenging, but still, we're glad that you joined Devoxx Ukraine online. So I will not steal more time from your talk. So please, the mic is yours. Just start.
Thank you. Okay, so I'm going to maximize my screen and hopefully it's gonna come up now. Okay, excellent. So the title of my talk today is why you should migrate to Java 11 right now. And that's based on some of the work that I have been doing over the last, I guess, 18 months, almost 2 years, working at New Relic. And by the way, this title slide, which has this kind of nice background on it, it's actually a stylized view of where we go in Oregon, in North America, to have our annual company retreat. And it's got mountains and woodlands, and it's really nice. So I like this title slide because it kind of reminds me and hope for some travel and for getting to see everybody again. Okay, so I do work for New Relic, and because of that, I actually have to show you this slide. And what it basically means, it's a safe harbor slide. If you're a publicly traded company, then if you give a technical talk, you have to show this slide. And basically, it says that you shouldn't make any financial decisions, or invest in any companies based on anything that I'm about to tell you in this presentation. Okay, this is purely technical information, and it's not for financial advice of any kind. Okay. So, for people who have not met me before, my name's Ben Evans. I use he, him pronouns, and I am currently the principal engineer and the architect for JVM technologies at New Relic. Before I started at New Relic, I actually founded the performance company JClarity with Martin Verberg, which we sold to Microsoft last year. So that's kind of an interesting startup journey as well. Before JClarity, I spent a lot of time working in banks and in finance. I was the chief architect for listed derivatives at Deutsche Bank, and I was working at Morgan Stanley during Google's IPO, which was quite a few years ago now. So normally, if this was an in-person conference, I would say if you want to hear those stories, then come and find me in the bar. But that's going to be a little bit difficult because I'm at home in Barcelona right now. As well as my career and the sort of corporate side, I've also spent quite a lot of time working with the community. I'm a Java champion. I won the Java Rockstar Speaker Award several times. I should probably update that because for younger people, they probably don't know what Java 1 is. It's been Oracle Code 1 for a number of years now. So maybe I should update the slide. Never mind. Apart from those two awards, I was also part of the Java Community Process Executive Committee. That's the body that creates and ratifies all new Java standards. And I served on that as a community representative for 6 years. And during all of that time, I was living in London and helping to organize the London Java community, where, along with Martin, I was one of the people that helped to found a project called Adopt OpenJDK, which I think that quite a few of you will have heard of by now. So that's me. That's a bit of background about who I am and what I've been doing. So let's turn to what we're going to talk about today. Well, today's talk is all about Java 11, and it's really grown out. The material I'm going to present has grown out of the discussions that we've had at New Relic about what we do with our own internal fleet, and also about how we support our customers. So I'm just going to send literally 2 or 3 slides introducing New Relic to you, because I know that not every developer has heard of them or has used our product. So it's important just to explain why we've been on this journey internally, I guess. And then I'm going to talk about Java 11 in context, and of course the real meat of the talk is why 11 is such an important release, and what those reasons, those good reasons and practical things that are good that happen to you when you go to 11. So that will be probably the longest section, and at the end we'll have conclusions, and then I guess we'll go for some Q&A in the chat room. Okay, sound good? So let's start off with just a couple of slides about New Relic. So New Relic is what is sometimes called a performance monitoring company, or these days the term very much is what's called an observability company. And the idea is modern software stacks are really complicated. Even if you're just a Java shop, which maybe has, a React front end to your application, software gets more and more complicated over time, and it gets harder and harder to figure out what's going on. So some companies, they try to build their own tools for trying to understand what's happening in their production systems. But the truth of the matter is that reliably building monitoring software is really hard. And for most companies, it doesn't, it's not their core competence. It's not something that, it's a cost center. It's something which is going to tie up their good engineers, and it's not actually producing business value. So companies like New Relic and our competitors exist basically to provide that service for you. So you can just not worry about how to understand what's going on in your production systems, how to instrument them, how to get the data and what the data all means, and that we will collect the data for you and bring it into a form that you can understand. And we handle billions upon billions of events from our customers per day. We're one of the largest observability and monitoring companies in the world. And we have a thing called New Relic One, which we describe as the world's first observability platform. So it's basically a single place to put all of your data about all of your systems in. We are very much an open source company. We recently open sourced pretty much all of our technology. One of the things I've been doing over the last 18 months is pivoting New Relic from being a mostly proprietary company to open sourcing virtually everything that we can. So, and now we just passed the milestone. All of our software agents and every bit of code that we put into a customer system is now completely open source, and we're building towards doing more with open standards as well, which is amazing. And for us, Java is really important. We are especially Kafka. So Java and Kafka is kind of our two biggest things that we use the most of. We actually have one of the largest Kafka installations anywhere in the world, and we have a lot of use of the Kotlin language as well. So this is the kind of the background, and our overall architecture kind of looks a bit like this. So if you imagine that this is the blue box is the New Relic architecture. You put a little blob of New Relic code, the agent, into your Java application or whatever other language you want to use. We don't just do Java. We do Java, but it's not the only thing that we cover. We cover pretty much every modern language and framework. And those agents report data into our pipeline, which is all kind of Java services and microservices all the way through. A lot of Kafka, and eventually there's a dashboard which displays your information back to you. So this is kind of the key part of our pipeline. And pretty much all of this is either Java or Kotlin. So we have thousands of JVMs, actually probably more like tens of thousands running at any one time. So we obviously are very conscious about what's going on. Java is a really important technology to our customers. It's also very, very important to us ourselves. So we were, when I first joined New Relic, we were right at the start of our journey with Java 11. So that was probably 18 months ago. At that time, Java 11 had only been out for about 6 months. And it was really not clear what the road forward was going to be. So having just done a brief introduction of New Relic and our architecture and why we care about it, let's talk about Java 11 in context. Let's talk about some of the things which have gone on in the ecosystem in recent years, which are important. And this is kind of not the sort of thing which developers normally are that interested in, but it is really important. We need to understand a little bit about licensing and about how Oracle's Java has changed in the last year. So it's coming up to 18 months now when Oracle actually changed their support model. And it does have huge impacts on the entire Java world. So if you haven't understood what those changes are, and a lot of people still don't, it's important to take a few minutes just to talk about that. So let's start by just doing a little bit of history, and then we'll talk about the release and support model. I'll talk about the new way that Java releases are developed on what's called a mainline model, and then we'll talk about OpenJDK 8 and 11, and then a little bit about future plans as well. All right. First of all, though, let's get into our time machine, and let's go deeply far back in time. Let's go all the way back to 1995, 25 years ago. It's incredible to me that much time has passed now, and that we're now talking about entering the second quarter century of Java, if you can believe that. It seems just impossible. I don't know where the time goes. There is actually another point here, which I think is worth taking just a slight detour just to mention, because I don't think people always realize this. When you think about Java, when you look at it, you should always remember that it was a language that was born in the late 90s. It's a very forward-looking a very opinionated and a very advanced language which is trying to push the envelope of software engineering. But it was a language which did all that 25 years ago. So when some people criticize Java and say it's very, old hat and it's very mundane and it's very middle of the road, well, it is now, but it wasn't back then. 25 years ago, it was out on the edges. It was cutting edge. And if it's mainstream now, that is because it correctly predicted the future. If it's mainstream now, it's because the mainstream has moved to where Java is. There's an old quote in American politics. Ronald Reagan once said, because he was originally part of the Democratic Party, he said, "I did not leave the Democratic Party. The Democratic Party left me." And with Java, it's kind of like that. Java did not become mainstream. The mainstream grew to accommodate where Java already was. So it's a good way to think about that in terms of why Java is the way it is. Anyhow, so 1995, Sun released Java. LiveScript, which was the original name for JavaScript, changes their name from Netscape to cash in just on the popularity and the tech hype that was surrounding Java. If you ever wondered why JavaScript has a similar name to Java, that's it. That's the only reason why. So that's our first milestone. This is a 10,000-foot view, a super high-level view of the history of Java. We're going to fast forward 11 years in one go. In 2006, Sun finally finish open sourcing Java. It takes them 11 years. And before that, Java is kind of mostly open source. A couple of things aren't, a lot of things are. And that basically led to some problems. And Sun finally got around to finishing the job in 2006, which, by the way, is when the OpenJDK project was born. Just one of the reasons I mentioned this here. Next big thing that happens after a jump of 11 years, a jump of only 4 years. 2010, Sun Microsystems run out of money and are on the verge of going bankrupt when they are acquired by Oracle. And Oracle basically take over Java and all of the other Sun technologies. So this gives you some idea of where we are. So Sun Microsystems ran Java for 15 years. Oracle have now run Java for 10 years. So it's not quite equal, but it's getting there. It's getting there. So Oracle, one of the main things they do is they convert all of their release train and the way that they develop Java so that it's based on the open source code base. And this is really important. Lots of people don't know this, but Java 7 is based on the open source code base. Java 8 is based upon the open source code base. All of the Oracle releases start from open source code as of Java 7. Okay. OpenJDK 6 is a bit weird. It actually doesn't quite correspond to a version of Java 6, but from Java 7 onwards, the Oracle releases are built on top of the open source code. Next up, we're going to jump forward another 6 years, and now that's taken us up to the release of Java 9. Java 9, the release model changes. So we'll talk about the release model in a second, but until Java 9, there has been one release model, which has been about the availability and the completedness of major features. So, for example, Java 8 did not ship until Lambda expressions were finished and they were actually ready, and they had no known high priority bugs. Yeah. Java 9 did not ship until modules were ready. And I want you to understand the difference in release model here between a model which is based upon an important feature and the release ships when the feature is ready, which is the old release model, Java 7, Java 8, Java 9. They're all based on that model that you don't ship until the feature is finished. Whereas from Java 10 onwards, so Java 9 was the last release on the old model. The new model, as we'll see, is purely time-based. And that is a subtle difference, but it's actually quite important in terms of the way that software is built and released. Okay, and then the final point, 2 years ago now, so September 2018, the current long-term support release, Java 11, was released. So that's another important milestone for us. I'm going to talk a lot about that. So just in case I haven't made this point sufficiently clear, let's hammer it home. Java has been open sourced since 2006, And since Java 7, Oracle JDK and OpenJDK are basically the same. If you're running your apps today on Oracle Java 8, it is almost identical to OpenJDK 8. And if you are a server-side developer, as I think most Java people are these days, there is virtually no difference. People sometimes think that there is a different JIT compiler or a different garbage collector in Java, Oracle's Java versus OpenJDK. That is not true. That is not true. So Java 9, OpenJDK is now the official Java. So with the release of Java 9, Oracle Java kind of disappears. Oracle start releasing OpenJDK binaries themselves. So the convergence is complete. For most people, there isn't really such a thing as Oracle JDK anymore. And unless you are paying money to Oracle, you don't really get access to the Oracle Java binaries anymore. Even if you go to the Oracle website and download them, if you're not a supported Oracle customer, you're probably downloading an OpenJDK binary. So OpenJDK is everybody's future. If you're going to carry on using Java, you are sooner or later going to end up running on OpenJDK. So this is it's not like the difference between Microsoft Office and OpenOffice or LibreOffice, where they're completely different products that just happen to support the same file formats. OpenJDK and Oracle JDK are basically identical. Talk a little bit about Java 9. So this is going 1 year back before Java 11, the version we actually care about. But it's just important to mention this. Java 9 was really late, and it has modules in it and the modular JDK, but it doesn't really have anything else. And it's the last release under the old model. And I sometimes, perhaps unfairly, refer to Java 9 as the Windows Vista release of Java. And that's not a bad idea to have in your head. Java 8 is kind of like Windows XP. It's a really solid release. People really like it, and there's absolutely nothing wrong with it. It will just keep on running, and Java 8 is going to be around for a long, long time. Because some people can't upgrade. Commercial companies go out of business and don't support their software on later versions, and so on and so forth. So I think there will be a legacy population of Java 8 for a long, long time. Java 9 is like the Windows Vista release. Java 11 is kind of like the Windows 7 release. So if you were in a corporate or an enterprise, when everyone held on to XP for ages and nobody really bought Windows Vista, but lots and lots of people went directly from XP to Windows 7. And if you think there's a parallel in there between migrating from Java 8 to Java 11, well, that's kind of what I'm getting at. So let's talk about the mainline release. Okay, so this is how it works. There are no big feature releases anymore. So there's no releases which are driven by a single most important feature like lambdas in 8 or modules in 9. That goes away. Instead, what now happens is there is a release of Java every 6 months, like clockwork. We've had Java 10, Java 11, Java 12, Java 13, Java 14, Java 15. We've had 6 releases already on this new model. So every 6 months, a new release is cut. If you are an OpenJDK developer and you are trying to create a new feature in Java, great, fantastic. If it gets close to the cutoff point for the release and you aren't ready, you are not allowed to merge to mainline. You have to carry on working in a branch, and you missed the release. Sorry, you got to wait for the next one. But you only have to wait for 6 months. So features are only allowed to merge to mainline when they are feature complete, and it's believed that they will be got down to 0 serious bugs before the release actually goes out. So that's really important. That changes the way that we develop software. Because now we have a regular schedule for releases, and features are merged when they're ready. But what it also means is that you don't end up with the problem, as happened with modules in Java 9, when there were a load of features that were stacked up behind modules that no one wanted to merge in because of the complexities of merging modules, and they basically didn't know how long they were going to have to wait to get their features in. So a regular release cycle, merging only when ready, promotes easier and less complex merges as well. However, there is a price to be paid for that. A new release of Java comes out every 6 months, but the releases are only supported for 6 months. So Oracle will only support a release for 6 months. So when Java 9 came out, it was only actually existed for 6 months. From 2017 in September to March 2018, when Java 10 came out. And as soon as Java 10 came out, Java 9 was marked as end of life. So if you want to stay at the cutting edge and upgrade your Java every 6 months, you can. And there are free binaries available from Oracle. And as long as you're prepared to keep upping your version number and every 6 months go from, well, currently it's Java 15. So if you're using Java 14, you'd have to upgrade to 15 now. And next March, you'll have to upgrade to Java 16. And then next September, you'll have to upgrade to Java 17. But if you're happy doing that, you can do that. And you can carry on using Oracle code. But there are no bug fixes, including security patches, after that 6 months is up. If you don't want to upgrade every 6 months, you have to do something else. And this is where the long-term support releases come in. So every 3 years, and the current long-term support release is Java 11, one release is designated as a long-term support release. And Oracle will sell you a support contract, which allows you to stay on that version and get updates. Currently, that's Java 11, and they basically kind of brought in Java 8 as a long-term support release as well. So Java 8 has also retroactively been classified as a long-term support release. So when I talk about people transitioning from Java 8 to Java 11, that is why. They are the long-term support releases. Now, of course, that's still all about Oracle and Oracle support. Now, what we actually see is that other vendors are also adopting the LTS model. Because, of course, the Oracle code is based on OpenJDK. So the changes that go back into Oracle's LTS versions make their way back into the open source version as well. So you cannot get free support from Oracle after the feature release arrives, and other vendors may or may not offer intended support. However, Java 8 and Java 11 are LTS, long-term support releases, and they are still continuing to receive patches, including security updates. So if you do not want to pay money to Oracle or anyone else, and you want to keep using a free Java, as in a free as in beer, as is sometimes said, that it's zero cost. If you want a zero cost Java, your only choice is to be on Java 8 or Java 11 and to go to another vendor other than Oracle. You cannot get free support on 8 and 11 with up-to-date security patches from Oracle for free. If you want to be supported on 8 and 11 by Oracle, you have to pay for it. But there are places you can get a free zero-cost binary for 8 and 11, which continues to be security patched. And that is the important thing that you have to grasp. So I've taken about, I guess, nearly 20 minutes already just to explain the difficulties of that licensing. And that is a problem. It shouldn't be that complex and difficult for teams to navigate. But it basically boils down to that. If you have money and you're prepared to pay Oracle or Azure Systems for binaries, then you can do that. If you do not want to pay money for a Java runtime and you want security patches, you have to go to OpenJDK. There is no other way of doing it. So you decide which you're going to do. Do you want to pay some money and go to Azure or Oracle? Or do you not want to pay money and go to OpenJDK? Okay, so the relevant versions we have the Java 8 LTS, which is 2014, which is 6 years old, right? That's the big thing to take away from this. And yes, it's still being security patched, but it's a 6-year-old runtime. Lots and lots of technical improvements have been made in that time. And right now, Java 8 is about 75% of the market. I know that because I work at New Relic, and our customers can choose to share data with us, and most of them do. And among the customers who've chosen to share data, which we think is about 1% of all of the Java virtual machines worldwide. So it's a pretty big sample. I mean, I see data from tens of millions of Java virtual machines every day. And based on those numbers, I can tell which version of Java people are actually running in production. Not a self-reported survey or anything like that. I see the actual production numbers. And I can tell you that about 75%, 70 to 75% of people are running Java 8. And the LTS release, it varies, but it's pretty much the rest. Java 8, let's say 75%. Java 11, between 20 and 25%. And the rest, well, there's 2 or 3% of people running Java 7 and below. And the rest is just noise. So there is nobody really running the strategy of adopting every new release as it comes out, and of upgrading every time a new feature release comes out. So there's not really any Java 9 or Java 10 or 12 or 13 or 14 or 15. It's Java 8 and it's Java 11, and that's it. So I think I've covered this, but Oracle's role is starting to diminish. OpenJDK is gaining more and more prominence, and the non-Oracle Java vendors are starting to get more important. You can still get free support, but only from an OpenJDK vendor, and only for versions 8 and 11. So those are your choices. So who am I talking about? Who are the new players in all of this? Well, there are some names I think that you're probably going to recognize on the next slide. Red Hat, of course, with their ICT product. IBM, who actually have a different virtual machine. The IBM offering is not actually based on Hotspot, which is the VM that most people know, but they have their own virtual machine called OpenJ9. And that's actually part of the Eclipse Foundation now. But they're still a strong player. Now, there's also Amazon, who produce a distribution called Amazon Corretto for AWS. And it's kind of interesting because, as you can see in the picture here, we've got Duke with an ice cream cone. Now, it's Devoxx. We're all adults. So I can probably tell you that a Corretto in Italian is not an ice cream. Instead, a Corretto is a double espresso with a shot of liquor, usually grappa, because it's Italy. And it's not ice cream, and it's not very family friendly. So I don't know what happened here. I think maybe they took the name Corretto because it was cool, and then the marketing department decided that they needed something a bit more family friendly. But never mind. The one that I'm most familiar with, and I'm still involved with in some ways, is Adopt OpenJDK. And this one is actually the largest producer of non-Oracle binaries in the world. Adopt OpenJDK is, after Oracle, the largest supplier of JVMs. So if you don't know what to pick, and you need to get off of Oracle because you don't want to pay money and you need security patches, Adopt OpenJDK is a great choice. If you work purely on AWS, then maybe Amazon Corretto. Sure. I mean, all of these vendors are good choices. There aren't any bad choices here. I tend to use Adopt OpenJDK, but I know a lot of people have a lot of success with Corretto as well. Two other of the smaller players, Azul Systems, they mostly have a paid-for offering, but they do also produce free binaries as well. And if you're planning to maybe buy a support contract, maybe try out the Azul free binaries first. And then, of course, Alibaba, who produced this distribution called Dragonwell, which is I think really designed for their own internal systems, but they also do make it available to people worldwide as well. So those are the new players. And when you start picking a distribution of Java, it's kind of like picking a Linux distribution. Do you like Debian or do you like Red Hat? Some people like one and some people like another. Other people, they might want to go and have Arch Linux, or I don't know, some other distribution which is out there, Gentoo even. But it's still the same Linux kernel, and it's still a lot of the same program code in each case. And that's very much the case for distributions of Java as well. Think of it like a Linux distribution. Okay, so we've talked, I think, about the mainline dev model, and so let's move on. OpenJDK 8 and 11 are now run by Red Hat, so Oracle engineers are no longer leading the OpenJDK projects at all. So let's talk about some of the future plans that are coming up. Well, there's obviously ongoing maintenance, security patches. That's the big thing that is still being put into OpenJDK 8 and 11. There's housekeeping updates. So things like, I don't know if people know this, but the Japanese era changed recently when a new Japanese emperor arrives. They have to create a new name for the era and a new kanji character to describe it. So that was, and by tradition, that is not announced until the actual the succession of the emperor happens. So that's not known ahead of time. So Java 8 needed an update to change the Japanese era and add the appropriate new characters to the Unicode character set. One other thing which was really difficult on Java 8 is Java 8 was still being built with a really old, nasty version of Xcode. So the build scripts had to be upgraded and changed to run with modern Mac build time zones, build tools. Time zones, of course, are a perennial problem. Again, were we in person, I would say, if you want to hear horror stories about time zones, come and buy me beer. And finally, TLS 1.3. As you probably know, TLS 1.1 is now known to no longer be safe. And TLS 1.2, at some point, I guess maybe 8-10 years from now, may also become unsafe as well. So just as a piece of future-proofing, TLS 1.3 support has been backported to Java 8. So OpenJDK 8 has been upgraded with some of these, what I would call housekeeping updates. So there is potential for some new things to be added, but only very small things. So Java 8 and Java 11, the OpenJDK and OpenJDK 11 projects, are all about keeping the lights on. This is a maintenance mode project. We're not going to backport major features from further versions of Java. Okay, so that's the projects. So let's move into the next section, which is to talk about reasons for going to 8 to 11. Now, there are a million talks out there that you could go to about things like local variable type inference, aka the var special restricted keyword. You could talk about modules and Java platform module system and all of that, and I'm sure many of you have been to topics about them. You can talk about the new HTTP client library and HTTP2 and how much better that's going to be for your microservices, and it probably will be. But I don't want to talk about any of those things because I'm just going to assume that you know what those features in Java 11 are. And if you have a need or a desire to use those things, then you don't need me to convince you about why you should upgrade to Java 11 right now. So I'm not going to talk about any of those things. And I know that you'll be able to find content about them on the internet if you are really interested in them. So let us talk to some things which you might not have thought about, which I think are important. And this is informed by my time at New Relic. A decent version of the G1 garbage collector. Did you know that the version of G1 that is in Java 8 is actually very different to the version that's in Java 11? Not many people know that. The version of G1 that is in Java 11 is actually really pretty good. The version in 8 is okay. I do have some services on Java 8 that are running G1, but I have been aggressively encouraging teams that if they want to use G1 as their collector, they should come to Java 11. Related to that is an improvement called compact strings. So you probably know that in Java, a character, a char, is 2 bytes because it's a Unicode character, not an ASCII character. So it's a 16-bit char type. Now, if you have a string, which underneath is really just an array of chars, you know that if your string is written in ASCII or another Western European language, the half of your strings are empty because they're 2-byte chars, and the first byte of each 2-byte char is always 0. So you are wasting a vast amount of space for any string which is Western European by encoding the strings as array of char with 2 bytes per char. Internally, in Java 11, there was an automatic optimization which changes the way that strings work internally, and they actually become arrays of bytes rather than arrays of chars. So straight away, you get back all of those missing 0 bytes. The actual production overhead of that, I have seen heap size reduction of 30 and 40%. And when combined with going from the parallel collector to G1, the garbage collection behavior of an application on 11 can be completely transformed. One caveat, and I will say this several times over the course of the remaining time we have today. When you go to Java 11, especially if you're going to go into containers, you may find that you need to give it more CPU, because G1 is a concurrent garbage collector. And because G1 is a concurrent garbage collector, you may need more CPUs available for your application. So you're getting a trade-off of much better GC performance, much smaller heap size, but to do that, you do need slightly bigger containers in terms of needing more CPU, just so that there is an extra core for when the garbage collector wants to run. So that's the first piece. The second piece is the performance improvements. Every time that a Java application is upgraded and goes to a new version, there is the possibility that there are some extra optimizations and improvements within the JVM which are able to speed up programs without recompilation. There are things like new JIT compilation intrinsics. There are changes internally which provide performance improvements. So generally speaking, upgrading will give you better performance. Java 8, especially below version 8 update 192, is not very friendly to containers. Very old versions of Java 8 update 102, for example, actually just ignore the fact that they're running in a container. And that can do very, very bad things to performance. Java 11, out of the box, is container friendly. It understands containers, and it will play nicely within a container without you having to do anything. So if you are running in containers, the GC and memory improvements that I've talked about, and the fact that the 11 is designed to be safe for containers, that is probably a good enough reason by itself to upgrade. What other things are there? A couple of minor things. If you do cryptography, you will find that Java 11 is much better. If you are running Java-based cryptographic, if you're terminating SSL or doing encryption, the services that do that will see much better performance on Java 11 due to improvements in the VM. And finally, it's future-proof. It's the long-term support release. So you can upgrade from 8, and then I tell my teams you don't have to upgrade again for a long time. So you get a small footprint, you get cloud friendliness, you get container friendliness, you get cool new tech to play with. And on the whole, I start to think that what will happen is I'll have a few teams that have sustaining business as usual applications that stay on Java 8. I'm already in the place where version 11 is what new applications start as now. So when a new application template is run at New Relic, it stood up automatically as a Java 11 app. And then there's a process that I'm going through of migration and getting people to upgrade and bring their services from 8 to 11. I think I've talked about all of this. So what do we need to know to go along with the Java 11 upgrade? Well, you just upgrade the JDK and it might work. But what you are more likely to find is that some of your library versions also need upgrading. And one of the things that absolutely stands out here is the ASM library, which is a bytecode manipulation library. Now, you may think, what's that? I've never heard of it. I don't depend upon ASM. Well, you may not depend upon it directly. However, I think that if you look carefully, if you expand out all of your transitive dependencies in Gradle or in Maven, you will find that probably all of your applications indirectly depend upon ASM. ASM is used by so many of the other libraries that are in the ecosystem that even if you don't use ASM directly, you probably depend upon something which does. And ASM is very specific about which versions of Java it plays with, because it manipulates the bytecode. It has to be you have to pick a version which knows about the version of Java that you're using. So an older version of ASM, version 5 or version 6, will not play nicely with Java 11. So then you have to work out from your library stack what libraries that you directly depend upon you have to upgrade to, and then take their transitive dependencies as well. So that's one occasional stumbling block. But basically, I just treat this as an excuse to clean house. We're upgrading from Java 8 to Java 11, so it's an opportunity to make sure that all of our library versions are up to date with the recommended level for Java 11. So it's not as simple as just flipping the JDK version, but it's not that bad either. It's just one of those regular exercises of tech debt reduction that people should undergo every once in a while. There are still some very small things that aren't Java 11 compatible. The only two that I know of, and this slide should actually say the Thrift compiler. Thrift itself is absolutely fine on Java 11. But I think there is still one outstanding bug that if you actually wanted to build a version of the Thrift compiler itself, you would have to build the Thrift compiler on Java 8. You could then run the compiler on Java 11, but it won't build under 11. And secondly, Cassandra. And this isn't a Cassandra client, this is a Cassandra node. If you're running an actual Cassandra node, you have to run it on Java 8 still. Cassandra 4.0 does support Java 11, but that has not become generally available yet. So we're still waiting on Java on Cassandra 4.0 before full Java 11 support arrives. So that's it. Obviously, if you're running a Cassandra client, that's fine on Java 11. Okay, so that's sort of a short list of the things that we need to know about. So why do we upgrade to Java 11? The first major reason that we gave is to do with licensing and how licensing has evolved, and the fact that if you don't want to have to pay money for Java support, you have to upgrade to Java 11 or OpenJDK. You could, I suppose, stay on version 8 and just move to OpenJDK and get security updates that way. But the second reason is really about cloud and container behavior and just better performance. It's Java 8 is a 6-year-old runtime now. So you get 6 years of major software engineering improvements from the people that actually make the platform for you. So it's just a good housekeeping exercise. If you're running in something like AWS, the fact that you can get away with much smaller heaps may actually mean that your AWS bill comes down. So there are potentials to actually save quite a bit of money here if you move to a runtime which is more suited to working containers in the cloud. One other major reason, I'm going to spend the last 10 minutes of my talk talking about this. This is really dear to my heart, the next subject. Java Flight Recorder. So I've been interested in performance of applications for many years now. The Google IPO, for which I was the performance engineer, was 2004. And it was, in those days, actually very difficult to get good, accurate performance data about Java applications. Java Flight Recorder is the tool that I wish that I'd always had in many ways. What is it? It's a profiling tool built into the JVM. It allows you to gather profiling data, diagnostics, and telemetry data from a Java application while it is running without needing to stop it. And in fact, you can actually dynamically start Java flight recordings from a Java application that is not configured for it. So if you start to notice your application is suffering, you can actually switch on Flight Recorder and say, hey, let's actually start capturing data now. I want to see what's going on. It has a long history. In fact, it originally, the acronym, it's always been JFR, but it didn't originally start being called Java Flight Recorder. Originally, its first name was JRocket Flight Recorder. Yeah, so it actually came from Oracle's acquisition, not of Sun Microsystems, but of BEA. So when they bought BEA Systems and WebLogic and the JRocket VM, Flight Recorder came in at that point. So they integrated it with Hotspot and they turned it into this proprietary tool, which was part of the Oracle JDK, and it's in Java 7, and it's in Oracle Java 8 as well, but it's proprietary, and you have to pay money to Oracle to use it in production. And as part of the reorganization and move to the new release model, Oracle basically decided to open source JFR as part of Java 11. So earlier versions of Java don't have it. The open source version is in Java 11 onwards. And there is actually a backport of Java Flight Recorder to OpenJDK 8. So there's a version of it in very recent versions of JDK 8 as well. But I typically think of it as a Java 11 tool. The most impressive thing about JFR is its low overhead. Now, Oracle have always claimed that the impact is about 1%. Having tested it quite extensively in the New Relic environment, we think it's more like 2 to 3%, which is still incredible compared to many profilers which have an overhead of perhaps 15% or even higher. A 2 or 3% impact is well within the tolerances that virtually all applications can take. So that's a solidly engineered piece of kit which is able to, because it is so deeply enmeshed within the JVM, it's able to produce this very, very low overhead, and it's a spectacular piece of engineering. So most people normally interact with Flight Recorder by a tool called Mission Control, or Java Mission Control, or JMC, which is a GUI tool. It's a desktop which sits on your Mac or on your Windows machine, and enables you to look through a pre-recorded Flight Recorder file normally. We'll see some screenshots of Mission Control in a sec, but first of all, let's just tell you how you use it from the command line. So you can start it up ahead of time, and you can say, I want to start Flight Recorder. I want to generate a flight recording of 200 seconds at startup, and then stop and dump the file out. Now that's okay. It's a bit simplistic, and it can be very challenging to work within containers, because how do you get the file off of the container? If you're in Kubernetes, how do you manipulate a file that's just been dumped onto the local file system? So fortunately, there is a streaming solution. There is a solution which you can use, but the problem is JFR streaming only exists in Java 14, which is not LTS. And we did initially think about backporting it to Java 11, but that was decided that was too much. That was a bridge too far in terms of what backports were going to be done into LTS versions. So there will be no streaming available in an LTS until Java 17 next year, which makes me kind of sad, because the Java 14 streaming is actually really, really nice. But not to worry, there's still more things we can do with JFR to help us. There is the J command. So if you are able to get onto the local machine and run a command on the same machine as the VM you want to get flight recordings for, you can use J command to do that. You can just say J command and the PID, jfr.start, give it a name, and then set it, and then it will run continuously at that point until you dump the recording, and then you can produce a file, and then you can stop the recording once you're done with it. However you do it, whether you do it this way or you do it with the command line parameter at startup, you'll end up loading.
Sorry about the slight delay, folks. Technology, isn't it wonderful? So this is the one of the screens you'll see in Java Mission Control, and if this looks a bit like an Eclipse IDE set of windows, then you guessed correctly. It's actually built on the Eclipse toolkit. So you can see in here the sort of down the left-hand side, you've got a bunch of different things that you could explore within this recording file. And this is basically showing a kind of a heads-up view where you've got some customizable things of different high-level telemetry that you might look at. You've got your CPU usage, the heap usage, and allocation rate. So this thing is absolutely churning through data. It's actually doing 32 gigabytes in a 15-second window. So it's doing at least 2 gigabytes per second, which is really pretty impressive. And if you're have very sharp eyes, you can look at the stack trace and you can see that what it says is it's actually a benchmarking tool from Amazon Corretto called Hypothesis, which is just one of the tools that I use when I'm doing performance work. So you can use this to explore the recordings, and there are some other nice things. For example, this is the memory histogram, so that you can show what the most commonly allocated types are happening within the recording. So this is all pretty nice stuff. You can step through. You can see detail, and I've zoomed in here quite a lot of the TLabs. So what I'm showing you here actually is the allocation behavior of each individual thread. And so what you can see is that, and this is from a real test application at New Relic, and we do a lot of Kafka work. So of course the Kafka thread is actually the one that's the busiest, and in just a period of, I guess, an hour, it's allocated 10 gig of memory, and you can see all the other individual threads which are there. So it's kind of nice. It can show you what the hot parts of your application are in terms of memory allocation very easily there. There's method profiling, so you can actually do sort of traditional execution profiling and seeing what classes and what methods tend to produce the most activity. So this is like a histogram of execution, I guess. There's other things in there as well. There's things like the JIT compilation, so you can see a compiler duration histogram, how quickly a method's being compiled, and what you can do from here is just to check that all of the methods that you care about are actually being JIT compiled, and so that none of your key methods are actually going to impact. Some very quick best practices. One of the ways that I use it, if I can actually physically access the machine, if I can SSH onto it, is to set JFR up in what's called a ring buffer mode, so that it basically constantly keeps the last window of time, maybe the last 1 hour of time in memory, and then I can use jcommand to dump the file. So if there is a problem, I can quickly jump on the machine, dump the buffer, and then I can go backwards in time to before the problem started on the machine and actually see what went wrong. There is an API for parsing the files, which I'm just going to show very quickly. The key class is recording file, and once you've got a recording file, you can basically just step through it in kind of like an iterator and take events out, and you can actually parse and analyze JFR flight recorder files by just writing a very quick bit of code. To finish off with the last couple of slides, I'm just going to mention that we actually have just released, as generally available, our support for Java Flight Recorder. It's called Real-Time Profiling for Java. It's open source, and you can install a little daemon on your machine, which will listen to Java Flight Recorder. It talks to it over JMX, and it sends the data up into New Relic. So if you install this daemon on all of your machines, you don't have to mess about with Java Flight Recorder files and starting and stopping them and archiving them or anything. You can just have the daemon running alongside your processes and send all the data up to us. And I should mention that it's completely free. So if you can sign up and you can send us up to 100 gigabytes of data, which I think will do you about 20 VMs without ever owing us a penny. So if you want to check it out and see how we're doing with it, I've included a few tiny screenshots of just an explorer view of how your VMs show up over time with just some color to show how hot or not they are running. We have flame graphs and all sorts of other telemetry information, which you can just view through our web-based interface. And it's part of the overall change that we see happening, that people are more and more embracing open source solutions and open instrumentation as we move to this world where we want observability to become this really open forum where more systems and more applications, hopefully all applications, will be able to use open source technology to see what's going on inside their applications and produce better software. So we're cleaning house, we're migrating to Java 11. It increases performance, it accesses cool new things like Java Flight Recorder. There are loads and loads of really great reasons to come to Java 11. And thank you very much.
Thank you. Thank you, Ben, once again for joining our online event this year. So again, I hope we will meet in person next year, and we will be glad to welcome you in Ukraine. So, dear participants, please join Q&A Zoom room with Ben and ask your questions. I'm sure the talk was very interesting. I'm already sure that we should migrate to Java 11. So if you are not yet sure, join the Q&A Zoom room and ask your questions and open discussion. Thank you once again.